Today we're going to be talking about deductive reasoning. Deductive reasoning is different than inductive reasoning, which we learned about the other day. Remember that inductive reasoning uses patterns and examples. Okay, so deductive reasoning, on the other hand, is going to use facts, rules, and definitions. So let's make a list of those. So it uses facts, rules, definitions, and since we're talking about math here, you might also hear about properties. That's another one. So any of these can be used to draw a valid conclusion from some given statements. Okay. For example, I might say, if I'm looking at this picture, I have some pretty little ice cubes over here, and I know that ice freezes at 0 degrees Celsius, right? So I would know that the water in this ice cube has to be 0 degrees Celsius or lower because of the fact that water freezes at 0 degrees Celsius. So we have a couple of examples that we're going to look at to see if they are using inductive reasoning or deductive reasoning, and we'll talk about why they are. Okay, so in this example, it says, in Miguelstown, the month of April has had the most rain for the past 5 years. He thinks that this April will have the most rain this year. Okay. So we're looking here and we're trying to decide, is it inductive reasoning, which we learned about in 2.1, or is it deductive reasoning that we're learning about today? So we have to decide, is this using a law or a rule, or are we using a pattern? And the key is going to be that April has had the most rain for the past 5 years. That's going to tell us that this is a pattern. Okay? And he's basing his assumption that this April will also have the most rain for this year based on the pattern over the last 5 years. So we know that for this one, it's going to be inductive reasoning because it uses a pattern. Okay, so let's look at another example. Okay, so in this example it says, Sandra learned that if it is cloudy at night, it will not be as cold in the morning as it would be if there are no clouds at night. Sandra knows that it will be cloudy tonight, so she believes it will not be cold tomorrow morning. Okay, so it says Sandra learned, okay? That means that she probably learned this like in a science class of some sort. And so basically she was given a rule by a teacher or somebody else that says if it is cloudy at night, it will not be as cold in the morning as it is if there are no clouds at night. Okay? So she is basing her assumption that it will not be cold tomorrow morning on this rule that she learned. So because this indicates that she was taught a rule, we're going to be using we're using deductive reasoning here to make the assumption that it will not be cold tomorrow morning. Okay? Now, with the deductive reasoning, we have to follow some really specific rules. So we've said that in the past that if we want to prove that a statement is false, then we just have to give one counterexample. Unfortunately, it doesn't work as easily the other direction. So just one true example does not prove that something is true. And so we say that that would not be a valid method of determining whether a statement is true. In order to decide if something is true, we've been given some different laws. So we're going to go over a couple of laws that will give us a valid method for proving whether a conjecture is true or false. The first law is the law of detachment. And this is actually a picture from your book on page 118. So if you need to see this a little bit more clearly, you can find it there. And so the law of detachment is going to say that if your statement, P then Q, right, and we said that that was the way we wrote our if-then statement. So if P, then Q is a true statement, and P is true, so if the hypothesis is true, then the conclusion is going to be true. Okay? And the example that they give us is If a car is out of gas, then it will not start. So we're going, like this is our given information, and they're usually going to give us two statements for that. Okay, so they told us if a car is out of gas, then it will not start. Okay, then we're trying to match up the other given statement and the conclusion and see if it matches what was given in this first statement. So next it says Sarah's car is out of gas. Okay, so that lines up with the P of the first statement, right? Because this would be P. Okay. Our conclusion is that then Sarah's car will not start. Okay, so that would be the Q portion of our other statement. And so you'll notice here it says, if a car is out of gas, then it will not start. Sarah's car is out of gas. Therefore, we know Sarah's car will not start. So we're just matching it up. And the key here is going to be, you have to have the two P statements, underlined in red here. Both have to be about the same topic, and they have to be saying the same thing. Okay? One is usually more specific than the other. Like in this one, the first statement is a car is out of gas. The second one is more specific. It's saying Sarah's car is out of gas. Okay? Then your Q statements also have to match up. And this is where we decide whether it's a valid conclusion or not. So we could put anything we wanted to here, but the only valid conclusion would be that Sarah's, which we get from this other statement, will not start, because that was the Q portion of the original given statement. Okay, will not start. So let's look at an example. Okay, so here's our example. So this one says, if a student turns in a permission slip, then the student can go on the field trip. So we're saying, okay, a student turns in a permission slip. This is our P. Then the student can go on the field trip. This is our Q. Okay, and notice this is our first statement. That's the one that everything else has to match up with. So then this one says, Felipe turned in his permission slip. Okay, so turned in his permission slip. This would be the P of the next statement. And so our conclusion is that Felipe can go on the field trip. Okay, so we have to double check. Do our two P's match up? Student turns in a permission slip. Felipe turned in his permission slip. Those match up. Okay, the Q's. The student can go on the field trip. Felipe can go on the field trip. Those match up. So this would be a valid conclusion. If it had said, then Felipe cannot go on the field trip, that would be an example of an invalid conclusion. In is the prefix that means not. Okay? Our next type of law that we can use with deductive reasoning is the law of syllogism. And again, this picture is taken from your book. You could find it on page 119 in your book. And this one works just a little bit differently. So you're going to notice here it says, if P then Q and Q then R are true statements, then PR is a true statement. And so I'm going to write just the Q's and R's and the arrows and the P's out. And so what you're looking for here is that there is an overlap. Okay? So if you have this overlap, they're saying you can skip this middle step and you could just start at the beginning and go to the end. So you could just have P then R. So the important thing here is we're going to be looking for that overlap. In their example it says, if you get a job, then you will earn money. Okay? If you earn money, notice that's the overlap, then you will buy a car. And so your conclusion combines the other two parts, the parts that did not overlap. Okay, so this is our next example, and you're going to notice we actually have two examples here, okay, that we're going to be looking at. And so, first of all, we've been given two sentences. Okay, so we want to identify the hypothesis and conclusion in each, and we're trying to see on this one if there's any overlap. So this says, if you do not get enough sleep, so that's our hypothesis, then you will be tired. Okay? If you are tired, so look, there's our overlap, then you will not do well on the test. Okay? So we're trying to decide which of these would be a valid conclusion. So remember, in order to get a valid conclusion, you're taking the parts that overlap, that's what I've got in blue here, and you are eliminating those. Okay? And then you're just combining the other two parts. So we're looking for the answer that says, if you do not get enough sleep, okay, you will not do well on the test. So that is answer choice B. Answer choice A is not valid because this one is saying if you are tired, which isn't anywhere, sorry, it is the part here, that if you are tired, then you will not get enough sleep. It's trying to use this part that we that we undid, or that we eliminated, excuse me, and combine it with the hypothesis of the first statement, and you can't do that. That's not a valid way to combine those two pieces of information. So feel free to write down any questions you have, and I will see you tomorrow in class. And thank you for listening, and I hope you have a lovely afternoon. Bye.